So today we'll be doing our presentation on nanoparticles found in food storage.
So this is the project overview. So our topic was about food storage, but we're mainly talking about infant goods. So the goals is to analyze the advantages and disadvantages of using nanoparticles in food preservation, examine the different kinds of nanoparticles used in these packagings and food preservations, and assess the safety and regulatory considerations related to nanoparticle usage in infant products.
So what type of nanoparticles are used? So we found that silver nanoparticles were widely used in these food packaging systems, and that because infants are so vulnerable and new to the world, these constant use of these silver nanoparticles can be very hazardous for them and their growth. A study showed that nanoparticles were shown in baby products like bottles, pacifiers, and breast milk pouches for newborns, and a lot of people raised concerns for that. Here we have a picture of a silver nanoparticle found in a baby bottle, and that it's cloud-shaped and 250 nanometers. So what is this application? So the article we used today was the silver nanoparticles found in the baby products. Um, So the test was they used 5 infant products, like two baby bottles, which is baby bottle A and baby bottle B, pacifier A and B, and a breast milk storage bag. These were selected to see the silver nanoparticle migration into these 3 food simulates, which was deionized water, acetic acid, and ethanol. Since newborns and adults have somewhat different physiological characteristics, there are worries about potential health risks associated with the growing amount of silver nanoparticles in infant items. Here, in the picture shown in the figure, we see the 2 trials that went on in this experiment.
So how are nanoparticles involved in the application? So there is something called the ultrafiltration experiment. The outcome agrees well with the findings of several previous studies. For example, a little percentage of silver may migrate from commercial plastic food containers as nanoparticles. There's another study characterizing migrated silver using the same ultrafiltration method, reported that silver in 4% acetic acid was mainly in ionic state. But in other simulates, such as water and 20% ethanol, the silver was in the form of nanoparticles. And because of their wide range of antibacterial qualities, silver nanoparticles have been added to the polymer matrices of food packaging or coating materials. And in the figure shown on the right, it shows how silver aggregates, how it migrates from the baby bottle into the water, the baby bottle being A, and then the B would be the image of the silver migrating. What current technology method is this improving upon? So, as mentioned in the previous slide, we have the ultrafiltration, and this is used to separate the silver nanoparticle and the silver in the food stimulate that was collected following the migration test to ascertain the shape of the migrated silver. Silver flowed through the milk through the filter membrane during centrifugation, leaving undissolved nanoparticles in the top layer of the membrane. Analyze the filtered solution using the same technique as mentioned for the migrating testing. So the formula below, you can see that's the migration test, using the proportions of the silver and nanoparticles. However, even though there is some disadvantages, an advantage is the cost. So compared to tedious, costly, and time-consuming conventional approaches, recent advancements in nanotechnology-driven intelligence and active packaging materials have boosted safety and real-time contamination identification at a low cost. And in the picture below, the picture below shows a way how the ultrafiltration works.
So here are our references. This is the website where we got our information from, and this would be our group charter, and that would be it. Thank you.
Thank you.